Okay, so this week we have binary trees. This is chapter 17, but on Revel it will be a different chapter. So what are binary trees? Why we need trees? Binary trees are just like similar to a normal tree outside. You will see some of the similarities. Usually what binary trees and why was the need of creating a binary tree? You have seen the arrays, right? You have seen indexes and the values associated with indexes. That was array list, right? Then what happened next was we thought of creating an address and making it a little faster with linked list, that every node will have a link to the next node, and then this node will have a link to the next node and next node and so on. And that linked list will have a front and a back, and the back will indicate the last node is null, that's the end of your list, and front node will have the starting uh, first value of your list. Now, the another scenario to make it more efficient and fast, it was introduced as trees. What tree does, like what if this linked list have two nodes, two addresses? It will hold the address for for this node, and this will hold the address for the next node. So adding two addresses to your nodes, it's to make it a tree. A tree, what is a tree? A directed acyclic structure for linked nodes, has one-way links between the nodes. As you can see, a sample tree is over here. From linked list, the starting point was front. Remember, from your linked int list videos, we created our linked int list class, and what we did was the front was very important, right? So if you have made front null, you have lost the list. And if you want to go through your linked list, you always look for your front. If your front is null, then do this, and if your front is not null, then go through the list. Like where front was important, front was the one holding the whole list together. In trees, we have root. This root is the most important one. So if your root is null, it means you don't have a tree. If your root is holding some value, it means there is a tree to look forward to. So no path wraps back around the same node twice. So there is no, as you can see, the arrows are in one direction. There is no path coming back. No arrow is coming up. One binary tree is, binary means two. You have seen binary maybe in CSAI 100, maybe heard about binary. CSAI 100, binary means 2, 0, and 1. It has on, off, yes, no, binary is like just two. One where each node has at most two children. So this is what binary tree, that's why we call it as a binary tree. Is this a binary tree? Use the chat. Is this a binary tree? The definition of binary tree is one where each node has at most two children. Yes, this is a binary tree, and a tree can be defined. Now, how you will define a tree? Tree has a root. These are the root is the topmost, who knows the address for rest of the node, who is holding together your tree. A root, just like from outside where you have the tree, your tree is standing on the root. Then you have some data values. You have left subtree and right subtree. This is your left subtree. Like if you take a look, this is an overall tree, and then this is a small tree. This is the root. These are the children. This is the root. These are the children. So this goes so on and on. So this is what a tree looks like. Computer science examples of trees, as you can see, you have seen this in your computers. You have AI decision making. You will see compilers like doing all the expressions with the binary trees. When you have precedence, that's all it comes with the binary tree. You have cell phone T9 dictionary. That's also an example of binary trees or trees in computers. Folders, all these are associated, they're going one after the other. There's opening branches, like that's kind of an example of trees. Okay. Now, trees are, as we started the CSCI 143, if you recall from my welcome video, I was emphasizing a lot on recursion, linked list, and binary trees, remember? So there we are, we have made it to binary trees. We are talking about binary trees, so we have made it till binary trees. Trees are a mixture of linked list and recursion. So that's what I was emphasizing, that you need to learn linked list if you have to learn trees. You need to learn recursion if you want to learn trees. So they are a mixture. It's, as at this point, I would say it's not that hard, but if you're feeling hard, that's okay. Just read the common remarks, student remarks number 1. One student said, my code doesn't work and I don't know why. And the other student said, my code works and I don't know why. So which student are you? Number 1 or 2? 1 or 2? My code doesn't work and my code works and I don't know why. So these type of situations is we are looking forward to in your binary tree class. So you will see such kind of scenarios that where you will be like, my code is working and I've had no idea how this is working and I don't know why this is working. And then there will be scenarios when you think your code should work and it's not working. So that's totally fine. It's like the toughest topic I say, because these three are the hardest topic, linked list and recursion in 143. And your binary tree is kind of a combination of these two, so it make binary tree more complicated. But it will be not. I'll try my best to chop it down into sections to make it easier for you to understand. There are some terminologies as a programmer you need to understand when it comes to binary trees. When I say node, then you should know what node is. When I say root, when I say leaf, branch, parent, child, sibling, like all, we have everything in this tree. So let's take a look what these terminologies refers to, what are their meanings. Node, you have already seen linked list, right? Remember, you can recall from linked list what node is, and that was a list node. And now we have a tree node, an object containing a data value, right? Remember the list node, you have a data value and the address for the next node. But when it comes to tree, it means that you have the data value and left and right children. So this is a node having the data value 1 and left and right children, right? This is the node having the data value 2 and left and right children. Root is the topmost node. When I say, where's your root, do something with the root, that you should know what root is. Root is the topmost node of your tree. This is the root, no matter what. You cannot change your root. You cannot say, this is my root. You cannot say, this is my root, this is my root. No, this is the root for this whole tree. Okay, root cannot be changed. Leaves, what are the leaves? A node that has no children. What do you think? Which numbers are the leaves? Which numbers are the leaves? Participate in the chat, otherwise I will start calling names. Which nodes are the leaves? 4, 5, 6, 7 nodes had no children are the leaves. These are the nodes having no children. You need to participate so that I know, are you being totally lost or you're following up? This is the time. If you have any questions, you can ask. Branch, any internal node, neither the root nor the leaf. What do you think? What is a branch? Neither the node, any internal node, neither the root nor a leaf. So we know this is the root. We know these are the leaves. What will be a branch? Which nodes are branch? 2 and 3 are the branch because they are neither the root and they are not the leaves. So these are the middle nodes are the branch. Now parent, child and sibling, that's what we will be talking about with the trees, that who's the parent child relationship, like you have seen that in inheritance. So it's kind of a repetitive process, but it's the same concept. Parent, who's the parent, child and sibling. As you can see, just resume. What do you think? Parent, child and sibling, who's the parent? 1 is the parent for 2 and 3, and 2 and 3 are siblings. 2 is the parent for 4 and 5, and 4 and 5 are siblings. 3 is the parent for 6 and 7, and 6 and 7 are siblings. Okay, does it make sense? Does it make sense? Okay. So any questions related to these terminologies, you need to memorize it. Yes, you need to remember these terms. You need to know what these leaves are, what branch are. It's not that difficult. You can just relate it to the tree outside of your house, that what is a root, where your tree is standing. So if you remove the root, the tree is gone. Leaves are the last nodes where they are not extending further. You have a branch are in the middles. The node is from the linked list. You have parent, child, sibling. You have already seen the concept in inheritance. Now the terminology number 2, some of the other terminologies which you need to memorize, or you can learn from more practice by looking at it. Subtree, the tree of nodes reachable to the left, right from the current node. You have full tree where every branch has 2 children. This is kind of a full tree. Height of the tree is 3, and level 1, level 2, level 3. That's how you're looking at the level. Height is length of the longest part from root to any node. That's the height. Level, it's like how, that's how you are calculating the level 1, level 2, level 3. And full tree is one where every branch has 2 children. These are the terminologies that will be used in your programming questions. Let's move on. So this is what your linked list was converted into a tree. That's how it was converted. So first your linked list looked like data and the address. Now what we have is data and left and right addresses. So a basic tree node stores data and left and right addresses. So multiple nodes can be linked together into a larger tree. As you can see, if you want to add more values to this node, you need to tell whether that you want to add the value on the left side or on the right side. And then if you want to add, you'll say dot next, dot left, that what we'll be using, because it's not about just next, because it's not one address. Now we have left and right, and add this value to left. And whatever the value you are adding to your tree comes with left and right addresses. And if they are not extending further, they are null. So this is how you are creating a tree. Let's create our in-tree node class just like we did for our linked int list, and we'll be creating our own in-tree class and adding some of the methods. Let's stop the share. Okay, so template for tree methods, these are the template. We will come back to this after our the traversal part. So traversal, what do you mean by traversal? What do you call in programming? These are just a terminology for programming. Traversal. Traversal means loop your code, and traversal going through your root. So there are 3 ways to do the traversal, which you need to understand: the pre-order, in order, and post order. So come an examination of the elements, a pattern used in many tree algorithms. So what pattern you will use? So let's take a look at the pre-order. What pre-order is: process the root node, then its left and right subtree. So if your code says write a pre-order for, or print your tree with pre-order traversal, so it means you are printing the root node first, then you are printing the left and right subtree. Which one is the root node? Which is 17 will be the output. Then left and right, you go to the left side, you print 41, right? Then you go left side, you print 29, then right side 6, right? That's how it will work. Let's move on to some values and we'll see. Write the pre-order of this tree. I want you to have pen and papers and write the pre-order. What do you think will be the values of pre-order for this given tree? Pre-order means print the left subtree root, then left, then right. Pre-order, root, left, and then right. If you have gone left, there is another subtree. So when there's another subtree, it means print the root, then go left. We're going left, there is another subtree. Is there another subtree? No, they are null. So it means after there's no left, so we'll go right, and then we'll come back and it's already printed. We go to the right side, which is another subtree, root, left, and right. What will be the answer for this tree when you print using pre-order traversal? Use the chat. Let me know if it's confusing. If you let me write in the chat, if you think I have no idea, you can do a direct chat and just let me know if you're working. Good job, Chelsea. You can share your answers in direct chat. It's okay if your answers are wrong. Any other answer? Anyone else working on this? Yes, the correct answer is 17. So how we are doing the pre-order? We are doing root, then left and right subtree. You print the root, which is 17, then you go left, that is 41. You print 41, then you go left, which is 29, because as you come left, there's another subtree. So when you see a subtree, it means root, which is 41, left 29, and right 6. So when this subtree left side of this 17 is done, you will go the right side of 17. Remember, it says root, left, and then right. So when you go to the right side of 17, there is another subtree. You will apply the same formula, root, left, and right. So you print, after printing 6, you will print 9, 81, and 40. Now take a look at in order. In order is process left subtree, then root, and then right. Trace the output. Process the left subtree, so it means you're going left with this. This is the root. We are not printing the root first. You are printing root in the middle, and then you're printing the right side at the end. Root. This is the root. Left side. You go to left. There is another subtree. What's the left? Is there any left? Yes, which is this is left. You print left. Then after printing left, you have to print root. Root, then right, then right. Okay, complete the in order. Root, left, root, and right for in order. And you need to memorize the pattern. For pre-order, it's easier to memorize that. Consider your root, that if it's pre-order, pre means first, so root comes first, then left and right. In order means in the middle, let's say, and root comes in the middle. And post order means root will come at the end. So that's how you can that's my easy way of memorizing it. You can find another way if you think there's another easy way to think about pre, in, and post. What is the answer for in order? What is the answer? It's left, root, and right. Left, root, and right. Is anyone working? Okay. For in order, I'll go over the answer. The answer will be in order. Look at it. Left, root, and right. This is your tree. This is the root. We'll not print the root, we'll go left side of the root, left. This is another subtree. So we will not print the root, we'll go left. So you will print 29. 29 will be printed first, then after printing left, then you will print root, then print right. So 29, 41, 6. After printing 29, 41, and 6, this is your left side of this overall root, right? So left side is done, you'll print the root, which is 17. Then right, when you go to the right side, you have left, root, and right, again same scenario, and the answer will be 81, 9, and 40. Let me write the answer, 81, 9, and 40. Any questions? Any questions how we got in order? No? Okay, let's take a look at the post order. Take a look at post order. It says left, right, and then root. Trace the output. Left, right, and then root. What do you think? Left, right, and then root. What will be the output for this tree? You need to trace the output. Doesn't matter if your answers are wrong, but you need to work and trace the output. I will start calling names if I don't see any answers in the chat. You can do a direct chat and just trace the output. Doesn't matter your answers are wrong. Good job, Jane. More answers. Post order, left, right, and root. Root will be printed at the end. Post order feels like the simplest. Left, right, and root. Good. I'm receiving multiple answers. Okay, let's take a look. Post order, left, right, and then root. This is your overall root, you go left. This is your overall root, becomes the root, you go left. Left, right, and root. So you will print 29, 6, 41. This is the root. After done with the left, you go to the right side. When you go to the right side, you again have a subtree. You will do left, right, root, and then at the end, overall root. So the answer will be 29, 6, 41, 81, 49, 17. Okay, any questions? You will be writing a code on this. Code that reads the tree and then it prints this way. So if you're not just understanding this hands-on concept, it's you need to ask questions where you are stuck, what's the confusing part? How we are printing the output. These are the answers. Any questions so far? Yes or no using reaction? No questions? Everything clear? No? Any questions? No questions. Great. Let's move on to our next tree. This one. Now this is a tree. Now tell me the pre-order for this tree. Trace the output. Again, your answers could be wrong. Trace the output. What was pre-order? I told you to remember it from root. That's easy if you remember it from root. Pre means root will come first, then left and right. In means left, root and right. Root will come in the middle. And post means root will come at the end, left, right, and then root. Write the pre-order for this overall tree. Pre-order. Okay, I got answers. Good job, Jen. Everyone is making same mistake. Okay, let's take a look. What pre-order does, root comes first. So root will be coming first. We have 42, you will print 42. Then left and right, you go left side, you have another subtree, which is null and this side, but you have 15, right? You will print 15 as a root. Then you go right side, you have another subtree. So what we do is we count them as a null. When you don't have a value on left side or right side, you count them as a null, but they are still a subtree. So the answer will be 42, 15, 27, 48. Left side is done, root is done, root comes first, root, left, and now we are going to the right side. As you went to the right side, you have root, print the root 9, then left side of 9, so which is 86. After 9 you'll print 86. Then left is null, so you'll go right side. When you go to right side, it's a small subtree again. After 86 you will print root, which is 12. Left and right, 12, 5, and this is null, so you will not write null. So 86, 12, and 5. Then right side, so you're done with the left side of 9. Now you go right side of the 9. So right side of the 9 is 3 and 39. That the answer for pre-order. Let me see if I can annotate and create. Does it make sense? Yes. Any questions? And let's do some. And okay, so these are all null. So when they are null, so you don't have value, so you don't print it. These are all null. And so now take a look. Pre-order, overall root, root, left and right. You print 42, root, you go left. Then this is the root, you print the root. Then left is null, you go right. This is the root, you print left. And then there's no right. Then you go to the right side of your root, overall root. And then there is again, you print the root, you go left side of your root. Then when you go left side, you print root. There's no left, you go to the right, you see root, print it, then go left and then go right. When you're done with the overall left side of this bigger root, then you go right side. Then you go right side, you see 3, there is no left, you go right, print 39, and 39 will be the last value to be printed. Now do the in order of this overall root. Answers in the chat, please. Okay, let's take a look. We have in order. What in order does? Left, root, and right. So we'll go left, left of this side. Then again, we'll go left, left of this side is null. So we'll print root and then we go right side. So 15 is printed, 15, we go right side. Then again, you have a subtree, left, root, and then right. So 15, 48, 27, right? Then 42, then right side. When you go right side, again, you have left, root, and right. You go left, there is no, again, 86, there is no left more, so you'll print root. Then you go right side. You go right side, then again, left, which is 5, then root, and then right. So 5, 12, and then there is no right side, so you'll go back, which will print 9. After printing 9, you go right side. After going right side, what we have? Left, root, and right. So there is no left. We'll print 3 and 39. Questions? Now do the post order. If you have any questions and if you're confused, do let me know. If you want me to repeat, I can repeat. Say it in the direct chat if you want. Otherwise, let's move on to post order. Yes, practice it is the website. They will have these problems. Otherwise, we will have in our class as well. So don't worry, we can practice in class. Okay, repeat. So for in order, what we are doing, let me, if possible, let me do this spotlight this. It's just the spot. Okay. So let's take a look. What we have is in order, which means root, left, root, and right. So this is your root. You will not do it. This is a bigger tree. Whenever you see a bigger tree, that's the rule you apply. You go left side of the tree. When we go left side, again, this is the rule you will apply. So this is a tree again. This is a tree. We'll print left side. Do you have left side to go? No, you don't have any left side because it's null. So you will print root. You will print root. You will print 15. Then the next rule is left, root, and right. So this left is null. We'll print it root. We are going right side. As we went to the right side, what we have is another subtree. Another subtree. So when we see another subtree, what we will do, we'll apply the rule again, left, root, and right. So left of this root, which is 48, print, there is no right. So, we'll print root 27 and there is no right. So have we gone through this whole process? Yes. Now we are done with the left side of this bigger root. So now we can print this root, which is 42. After printing 42, it means we have to go right side of that tree. When we go right side of this tree, we see another subtree, 9. So the rule is left, root, and right. Does 9 have left? Yes, 9 have left. And so it means we will go left. So it means this 86 is holding another. I think I'm making a mess right now. This is another subtree. When we went to the left side, this is another subtree where you have left, root, and right. So it means left is null. So we'll print 86. I'm just following on to the next line. We printed 86 because left, root, and right. As we went to the right side, there is another subtree, right? When you have another subtree, so far we have 15, 48, or 27, 42, and 86. Now another subtree, let's pick another color, which is this one. And again, we have to apply the same rule, left, root, and right. Does this subtree have left? Yes, which is 5, 5, root, and right. So 5, 12. So right is null. We will not print. Are we done with these values? Yes. So now we can print this root where we started because we went to the left side and then we did so on. So now we can print 9. And now we will go right side. We have printed root, right side of the tree, right side of this. So when we went to the right side, there is another subtree. As you can see, this 3 have null and 39. So this 3 is basically not the purple. Again, you will apply the rule, left, root, and right. Left is null, we'll print root, which is 3, and then right, which is 39. And this is your in order. Questions? Was it helpful using multiple colors, or did it confuse you more? Okay, glad you. Okay, now do the post order. Same way, they have the same coloring like here. The values will be different. For post order, we have left, right, and then root. Root comes at the end. Trace the output. Good job, Preston. Good job, Tesfaye. Okay, so let's take a look. For post order, root comes at the end, left, right, and root. So what we will do is we'll go left, all the way left. This is your tree, left, left, null, we'll go right. So right of this root, again, when you go right, again, there is another subtree where you have to apply left, root, and left, right, and root. Left is 48, 48 will be printed. Right, null, then root, print the root, which is 27. Now as we have done the left, we have done the right, we'll print the root, which is 15. This is the left of this root is done. So we'll go right side of this root. When you go right, again, purple have the same rule, left, right, and then root. So as you go to the left, you entered into this blue subtree. Again, apply left, right, and root. As you have applied left, left is null. Then the second scenario is go to the right. As you went to the right, you have a green subtree. Again, you will apply the same rule, which is left, right, and root. So you will print left, which is 5. Right is null. You'll print root, which is 12. Then this was left, right, then you will print 86, the root. I'm just moving on to the next line. As this is done, then we'll go right side, where we have again, as we are not printing 9 and 42 yet, right side of this 9, we have left, right, and root. So after 86, we have 39, then we have 3, because left, right, and root. Left is null, right, root. Right side is null, done. We will print 9 and then we'll print 42 at the end. This is the answer. Any questions? Every subtree, you will apply this rule, left, whatever the pre, in, or post you are doing. So left, right, and root. So, and you'll work accordingly. Any questions? You want me to repeat? Does this make sense? Yes, no, reactions? Okay, repeat. Quickly take a look. We have left, right, and root. This is your bigger tree, 42. 42's left is this one. When you go left, they have yellow subtree. You will apply the same rule. Left, right, and root. As you go left, this is null. We'll go right. Right have another subtree, which is this orange one. Again, same rule. Left, right, and root. We have left is 48. Right is null. So we'll print 48. Then right is null, will not print anything, and root, which is 27. After printing 27, this orange tree is done. So it means left and right of this 15 is done. So now we can print 15. After done with this bigger right side, left side of this 42, the concept is left side is done. Now go to the right side of this 42. Now, as we entered the right side of this 42, we have this purple. So again, we'll apply left, right, and root. As we entered left, this 86 is holding blue one, another subtree. So again, same rule, left of 86 is null. We'll go right of 86, which is 12. As we entered right of 86, there is another subtree. We will apply the same rule, left, right, and root. Left of 12 is 5. So we printed 5. After printed 5, right is null. We'll print root, which is 12. Left, right, root, left, right, which is done. We after printing 12, print the root, which is 86. Right is done. Go to the left of 9. Left of 9 is 3. And left, right. Left is null. Right, which is 39. Print the root, left, right, and root. So we printed 39 and 3. After printing 39 and 3, left is done, right is done, we will print 9. And for 42, left is done, right is done, and now you can print at the end 42. That's the concept of post traversal for the trees. Left, right, and root. Okay, so let's move on to similar more questions. Let's see if we have. For that, first you need to understand binary search tree. So I have more questions related to this, which we can practice. For that, you need to understand the binary search tree, which will make your life so much easier. But binary search tree, previously what you saw was binary trees. And that was just binary tree means every node have 2 children. What binary search tree rules have is, these are very important rules, that tree is either empty, which is null, or right of root node, such as every element of the root or left subtree contains data less than the root. And it means the tree is basically sorted. So if you're going right side, you have greater than the root. If you're going left side, the data is less than the root. So as you can see, whatever the first value user give, that becomes the root. And after that, more values are coming in, it will be compared with your overall root. So if 87 pops up, 87 is, you will check 87 with your root. Is 87 greater than or less than your root? If it's greater, it will go to the right side of your tree. And if it's less, like 29, it will go left side of your tree. And as the values coming more forward, like 42, 42 will be compared with 55. Is it less? Yes, you go on this side, then it will compare it with 29. Is it less or greater? It's greater, so it go right side of that tree. So as you can see, these are all trees. Every tree have a root, but major root, the bigger root is this one. And as if I want to add more values, let's say -2, where -2 will go? -2. -2. Is -2 greater than 55? So it will go less, so it will go onto the left side. Is -2 greater than 29? No, it will go left side. Is -2 greater than -3? So it will go right side of -3. Where 100 will go? 100. Right of 91. Correct. That's how the binary search tree will work. So these are some examples. Binary tree, a search tree have some rules. They are in sorting order. As you can see, all subtree contains data less than arts data on the left side, and right side have data greater than the root. And binary search tree that is either empty or the root is like this. Okay. Okay. I think, where would we add the value 3? Where 3 will go? This is, consider this is a binary search tree. First add 14. First add 14. Where 14 will go in this binary search tree? 14 is greater than 8, right side. 14 is greater than 11, right side. 14 is less than 18, left side. Right? Where 3 will be added? Add 3 to this tree. 3. 3 is less than 8. 3 is less than 5. 3 is greater than 2. 3 is less than 4. Where 7 will be added? 7. One thing, there are no duplicates in binary search tree. So if there is a duplicate, you will not add that value. No duplicates in binary search tree. If the tree is empty, where should a new value be added? If the tree is empty, where should the new value be added? It will be the root. So if there's the tree is empty, whatever the value you have given, that will become the root. 3 go next to 4. Next 4 over here, why the left side is holding lesser values. 3 is greater than 2, so it will go right side of the 2. As you come to the right side, you have 4. So you will compare 3 with 4, whether it's go right side of 4 or left side of the 4. Okay, so you have there's couple of values. Let me clear the drawing. Create a binary search tree. Create a binary search tree. These are the values in order. So create the binary search tree. Draw it. Draw the binary search tree. What will be the root node? What is the root value? 50 will become the root. Where 20 will go, right or left? Right or left? Left. 75, where 75 will go? Right of 50. 98, where 98 will go? Right of what? Right of 75. Where 80 will go? 80. Left of 98. 31. Where 31 will go? Right of 20. 150. That's easy. All the way right to 98. 39, where 39 will go? 39. Right of 31. 23. 23. Left of 31. 11. 11. Left of 20. And last, 77. 77. 77. Left of 80. This is your binary search tree. Now the questions are like, these values are given, create the binary search tree. So if your tree is wrong, even if you just misplace one of the values, your pre-order, post-order, in-order, rest of your question will be wrong, right? So if your tree is wrong, if you have created or misplaced your tree, then your pre-order, in-order, and post-order will be wrong. Any questions how you create binary search tree? Just like that with a graph? No? Let me start with the questions. And for just one practice, let's do this one, because I think we have only time for that. This will give you an idea how the questions looks like for these type of scenarios. Okay, this one is interesting. Share screen. You have not done this before, but you know the concept, and that's what they do in exams, you know. Can you see my screen? Binary search tree. Can you see the screen? Okay. Write the binary search tree that would result if these elements were added to an empty tree in this order. And then you have to write the pre-order, in order, and post-order. Create the tree of these values. These are your values. Draw the tree. Okay, who's the root? Meg. Then where's Stewie will go, right or left? Right, okay. If you're done creating the tree, I want you to work on pre-order, post-order, in order. Meanwhile, I can just. I'll be just using the letters, first letter. Compare your answers. On this side, then we have any questions? How we got the tree? Is your tree look similar to mine, or do you have any something else? Any changes? Something different? No? Okay, how would you get that? Okay, so you are doing the alphabetical order. So you're going with the alphabetical order. M is the Meg. Meg is there first, so we will start with Meg, and we'll put Meg as the root node. And whatever comes next, we are comparing Stu, Peter, Joe with M, and then rest of the letters. So where M The next word is stew. So does S come before M or after M? S. So if you have duplicates of the name, for example, you have, let's say, Cooper, and you have both of them are C. So you will start with the second letter as well, looking for their alphabetical order. So after M comes after, sorry, S come after M. So S will go, S is greater, it will go right side of M. Peter, then you compare P with M. Does P comes after M? Yes. You'll check S. Does P come after S? Yes. So you'll, or sorry, before P, because you're like PQRS. So P comes before S. So it will go onto the left side of S. Then you have Joe. Joe comes before M, left side, and it's just there. Then we have Lewis, L. You compare M with L. Is L comes before M or after M? L comes before. So you go on to the left side. Then you compare L with J. Does L come before or after? It comes after, so it will go right side of J, and so on. Anything which confuses you, complete the chart if you have not started or had no idea how to get started. Now, after you have this tree in front of you, you have to do the pre-order, in order, and post order. What pre-order was, print the root first, then left and right. So root is M. So M is first. This is your pre-order. What's the next one? What's the next letter? Or you can tell the name. Pre-order. J. Root, left and right. After J, B. Quick, we have only 4 minutes left. Pre-order, we are doing root, left and right. So this is your root. We printed the root. Then we go left side. In left side, you have another subtree. You print the root, which is J. Then you go left side. Then when you come to the left side, you have another subtree. You print the left side. There is no left. You print, you print the root first, which is B. Then left, there is no left. You print the right, which is C. After printing C, you go, you are done with the left side. You're coming back to J, where you are, you're done with the root left, and now you complete right, which is L. And then you are done with the left side, root left. Now you're going right side. When you're going right side, you have another subtree, which means root. Sorry, this is L and this is C. Root, left and right. So root is S, you'll print. Then you have left and right. So you go left, you have another subtree. There is root, which will print P, and then there is no left, so you will print Q at the end. Okay, so this is your pre-order. Now, what will be in order? In order is root comes in the middle, left, root, and then right. You go left, you have another left, you have another left. Nope, no left here. So print the root, which is B, and then right. So B and C. So this subtree is done. Here the goal was left, root, and right. So left is done. Print the root, which is J, and go to the right side. When you go to the right side, you only have L. And as the left side is done, you'll print M, which is the root, and then going to the right side. As you went to the right side, again, you'll apply the same rule, left, root, and right. So left, as you went to the left, there is another subtree, so we'll go left. There is no left here, so we'll print root and right, so which is P and Q, and then the left side is done. We'll print the root S, so there is no right side, so all done. This is your in order. Now we have post order. Post order means left, right, and then root will be printed. So left, left, left. So this is null. So we'll stop here. Left is null. So our goal is left, right, and root. So left is null, right, and root. C and B. So this subtree is done, which is left, right, and root. Now left of this J is done. We'll go right, which is L. So left, right, and root. So this is done. So left of this root is done. We go right of this root, we have S. So we go left, left, again starts as long we don't see any left. This is where left is now, we'll print right and root. So this is another tree, right and root, which is Q and P. So left of S is done, right is now, print the root, and right of this overall root is done, print M at the end. This is your post order, pre, in, and post. Any questions so far?